Welcome to AI Research Weekly, the show that dives deep into the bleeding edge of artificial intelligence. I'm Nova.
And I'm Onyx. This week, we've got a fascinating mix of strategic industry shifts and some surprising performance benchmarks that are really pushing the boundaries of efficient model development.
Absolutely, Onyx. It feels like we're watching the industry mature right before our eyes, not just in terms of model capabilities, but also in how these systems are being deployed and governed.
That's a great point, Nova. We're seeing a convergence of cutting-edge research translating into tangible products, while simultaneously, the regulatory landscape is beginning to take shape. It's a dynamic environment, to say the least.
All right, let's jump straight into it. One of the most talked about developments this week comes from NVIDIA, specifically their NVARC team, who absolutely dominated the Kaggle ARC Prize 2025. They achieved a 27.64% score on the ARC AGI-2 benchmark with a fine-tuned 4 billion parameter model. That's a big deal.
It truly is, Nova. The ARC AI2 benchmark, for those unfamiliar, is notoriously challenging. It tests a model's ability to generalize to novel tasks from very few examples, demanding a form of abstract reasoning that traditional deep learning models often struggle with. NVIDIA's achievement here isn't just about a high score, it's about how they achieved it. A 4 billion parameter model, outperforming significantly larger contenders at a reduced cost, signals a major breakthrough in efficient AI.
That's what caught my eye. We've been in this arms race of scaling up parameter counts, chasing diminishing returns. So, seeing a relatively modest 4B model deliver this kind of performance on a complex reasoning task, it makes you wonder about the architectural or fine-tuning innovations at play. What's your take on the how here, Onyx?
My initial read suggests a confluence of highly optimized data synthesis and robust, multi-stage fine-tuning. The ARC-A tasks are inherently about pattern recognition and rule inference from visual grids, often requiring an internal conceptualization of operations. I suspect their fine-tuning strategy likely involved a strong curriculum learning approach, where the model was exposed to progressively more complex, synthetically generated ARC-like tasks. This would allow it to internalize fundamental reasoning primitives before tackling the actual benchmark.
So, it's less about raw scale and more about the quality and structure of the pre-training and fine-tuning data, alongside potentially some inductive biases in the model architecture that facilitate abstract pattern matching. Are we looking at new forms of meta-learning, or perhaps even some programmatic synthesis integrated into the training loop?
Exactly. It's highly probable they leverage some form of programmatic data augmentation, generating a vast, diverse set of training examples that explicitly target the combinatorial nature of ARC tasks. Think about training a model not just on input-output pairs, but also on the rules that transform inputs to outputs. The fine-tuning phase would then solidify these conceptual understandings. Given the 4B parameter count, I'd also wager they employed very aggressive regularization and perhaps even knowledge distillation from a more complex, albeit less efficient teacher model during an earlier stage. The efficiency gain is too significant to ignore.
Interesting, but what are the limitations here? While 27.64% is impressive, it's still far from human-level performance on RC. Are we still facing the same generalization walls, just with a more optimized path to reach them? And does this approach scale beyond these specific grid-based reasoning tasks?
That's the critical question, Nova. While it represents a leap in efficiency for a specific type of abstract reasoning, the generalizability to open-ended, real-world reasoning tasks remains to be seen. The ARC benchmark, while hard, is still a closed-world system with well-defined constraints. Extending this fine-tuning paradigm to tasks requiring common sense, world knowledge, or complex language understanding would require an entirely different data generation and curriculum learning strategy. It's a significant proof of concept for targeted reasoning, but perhaps not a universal solution for AGI. The next step would be to see if these learned inductive biases can transfer effectively to broader domains with minimal additional training.
That makes sense. It highlights the continued importance of data engineering and curriculum design, even as base models grow larger. a compelling reminder that optimization isn't just about flops anymore.
Indeed, the data-centric AI paradigm continues to prove its immense value. This win from NVIDIA really underscores that.
Shifting gears a bit, let's talk about the buzz around Meta's new flagship AI model, Muse Spark. This is the inaugural release from their revamped Superintelligence Lab. Superintelligence Lab is quite a name, Onyx. What does this model release and the new lab signify for Meta's broader strategy?
It signifies Meta's unambiguous declaration of intent to compete directly and aggressively with OpenAI and Google in the frontier model space. The naming of the Superintelligence Lab is very deliberate, signaling a long-term, ambitious research agenda beyond current LLM capabilities. Muse Spark itself, as a flagship model, implies a significant leap in scale, architectural innovation, or multimodal capabilities compared to their previous offerings like Llama.
So they're not just releasing another open-source LLM. This is a strategic play at the high end. What kind of architectural innovations might we expect from a model Meta is positioning as a flagship from a superintelligence lab? Are we talking about novel, sparse attention mechanisms, perhaps a mixture of experts architecture that goes beyond what we've seen, or even deeper integration of retrieval-augmented generation at the core?
All of the above are possibilities, Nova. Given the competitive landscape, I'd lean towards something that pushes the envelope on efficiency at scale or multimodal reasoning. Meta has historically invested heavily in multimodal AI, so a strong, natively multimodal architecture for Muse Spark, capable of seamless reasoning across vision, text, and potentially audio, would be a logical step. They might be integrating a more sophisticated world model or persistent memory mechanisms to move beyond the typical stateless transformer. We could also see a novel tokenization scheme or even an agentic framework built directly into the model's inference capabilities, allowing for more complex, multi-step problem solving. The term Spark itself could hint at a lighter, more agile inference engine that still delivers top-tier performance.
That's an interesting point about the Spark moniker. If it combines top-tier performance with efficiency, it would be a substantial differentiator. But the biggest challenge for any new flagship model, especially from a company like Meta, will be evaluation. How do they convince the research community and the industry that Muse Spark isn't just another large model, but truly represents a significant advancement?
Transparency will be key, Nova. Releasing detailed technical reports outlining the pre-training methodology, dataset specifics, architectural innovations, and comprehensive benchmark results across a wide array of tasks. Not just the standard language benchmarks, but also reasoning, code generation, and multimodal understanding will be crucial. Furthermore, demonstrating robust performance on adversarial examples and showcasing its ability to handle complex, novel prompts that challenge current state-of-the-art models will build credibility. If they aim for superintelligence, they'll need to demonstrate more than just scaled-up pattern matching. They'll need to show emergent properties in generalization and complex task execution.
It's an exciting development, and I'm keen to see the technical deep dive once it becomes available. The industry thrives on this kind of competitive innovation.
Absolutely. The more frontier models pushing the boundaries, the better for the entire field.
All right, let's move into our Industry Watch segment where we look at the major commercial and policy movements shaping AI. And Onyx, this week has been particularly heavy on policy.
It certainly has, Nova. The White House has released a national legislative policy framework for AI, which is a significant move towards comprehensive AI regulation in the U.S. This framework is not just a set of suggestions, it's a clear signal of the government's intent to shape how AI is developed and deployed, impacting every facet of the industry, from research labs to product rollouts.
This feels like a moment of reckoning, doesn't it? We've seen various executive orders and guidelines, but a legislative framework indicates a much more serious, structured approach to embedding guardrails into law. What are the immediate implications for researchers and engineers? Will this accelerate efforts in explainable AI, robustness, and safety, or could it potentially stifle innovation with overburdensome compliance?
It's a dual-edged sword, Nova. On one hand, It will undoubtedly mandate increased investment in areas like AI safety, transparency, bias detection, and adversarial robustness. For instance, any new models deployed in critical applications might require stringent impact assessments and audit trails, which aligns perfectly with current research trends in responsible AI. This could lead to a surge in funding and attention for these areas, moving them from niche academic interests to core engineering requirements. On the other hand, the devil will be in the details of the actual legislation. If the compliance burden is too high, especially for smaller labs or startups, it could indeed slow down rapid prototyping and experimentation. There will be a strong push for standardized evaluation protocols and verifiable safety metrics, which is a research area in itself.
I can see a scenario where this framework directly informs future grants and funding priorities, especially from federal agencies. If the government is prioritizing safety and accountability, then research proposals that explicitly address these aspects will likely gain traction.
Precisely. We'll see a shift where benchmarks will not just be about performance, but also about safety, fairness, and interpretability. This framework effectively elevates the importance of responsible AI research from an ethical consideration to a regulatory imperative.
Staying in the industry, C3 AI launched C3 Code, an enterprise AI development platform. They're touting it as a natural language interface for creating production-grade applications, combining autonomous agentic coding with their C3 Agentic AI platform. This is squarely in the rapidly evolving space of agentic AI.
It is, and it's a very pragmatic application of agentic research. We've seen a lot of academic exploration into multi-agent systems and autonomous agents for code generation and task orchestration. C3 AI is taking that research and productizing it for enterprise. The key here is production-grade applications. This implies a level of reliability, error handling, and integration capability that goes beyond typical proof-of-concept agentic systems. It suggests they've made significant strides in grounding these agents in real-world APIs and enterprise workflows.
So, it's not just a fancy wrapper around a large language model. This is an attempt to create truly autonomous development agents. What are the underlying technical challenges they would have had to overcome to make this viable for enterprise use? Things like consistent output, dealing with ambiguity in natural language prompts, and crucially, security and access control when an AI agent is interacting with production systems.
Those are precisely the challenges, Nova. For enterprise deployment, the agent needs robust planning capabilities, error recovery, and the ability to operate within defined security perimeters. They've likely implemented sophisticated guardrails, perhaps using a hierarchical agent architecture where a supervisory agent oversees code generation and execution with strict validation steps. Prompt engineering alone isn't enough. It requires strong tool integration, dynamic environment sensing, and possibly even formal verification methods for critical code segments. The C3 Agentic AI platform likely provides that underlying scaffolding for orchestration and controlled execution, which is a significant architectural undertaking in itself. It's moving beyond just writing code to orchestrating complex software development lifecycles using agents.
This also brings up interesting research questions around the human-agent collaboration model. How do developers debug an autonomous agent's thought process when it makes a mistake? How do you ensure the agent's generated code adheres to enterprise coding standards and best practices without explicit, exhaustive prompting every time?
Excellent points. The human in the loop will shift from writing code to guiding and validating agentic outputs, which necessitates new forms of interactive debugging and interpretability tools for these agent systems. This is a fertile ground for human-computer interaction research intertwined with explainable AI. If C3 AI has cracked even a portion of these challenges for their platform, it's a strong indicator of where enterprise software development is headed.
And finally, on the product side, Google has integrated its Gemini AI system extensively into Google Workspace. This means automatic content generation across docs, sheets, and slides. While this is a product rollout, it signifies the maturation of generalist LLM capabilities.
It's a huge step in democratizing advanced AI for productivity. The research implication here is less about a novel architectural breakthrough and more about the power of fine-tuning and robust API integration. Taking a large generalist model like Gemini and effectively specializing it for specific high-value tasks within a productivity suite requires immense effort in domain adaptation, prompt optimization, and user experience design. It's a testament to the versatility of these foundational models when given the right scaffolding.
I agree. It speaks to the ongoing challenge of making these powerful but often unwieldy models truly useful to everyday users. The last mile problem, if you will, for LLMs. But it also highlights the continued competitive pressure to deliver practical AI features.
Exactly. The integration isn't just about adding features, it's about fundamentally changing how people interact with their productivity tools. It shows that the industry is moving past experimental demos to deep embedding, where AI becomes an invisible co-pilot. This pushes research into areas like proactive AI, where the model anticipates user needs, and context-aware generation, where it understands the nuances of an email thread or a spreadsheet's purpose without explicit instruction.
So looking ahead, what's on your radar for the coming weeks, Onyx?
I'm keenly watching for further technical disclosures on Meta's Muse Spark, particularly around its multimodal capabilities and any new architectural paradigms. I also expect the discourse around the White House's AI framework to intensify, leading to more specific research initiatives focused on regulatory compliance and auditable AI. We might even see new benchmarks emerge that specifically target these compliance aspects, beyond just raw performance.
And I'll be interested to see how the lessons from NVIDIA's ARC Prize win, particularly around efficient fine-tuning and data synthesis for reasoning tasks, start influencing broader research. Will we see more groups prioritize sophisticated data strategies over brute force scaling? And for the agentic systems, how quickly will the enterprise solutions like C3 code mature, and what new research challenges will they reveal in terms of reliability and safety?
It's going to be a fascinating period, Nova, with research and industry developments feeding into each other at an unprecedented pace.
Couldn't agree more. That's all the time we have for this week's episode of AI Research Weekly. Thank you for joining us.
And we'll see you next time as we continue to explore the cutting edge of AI.